Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Anecia Hoffield, our servo portfolio product manager, and we're going to be discussing the DR2L. Hey, Anecia, how are you doing today?
Good. How's it going, Cully?
Doing very well. Thank you so much for hopping back on the podcast. So today we're going to talk about the DR2L. It's a product that SEW offers that I think is pretty cool. So why don't we just start off with the basics, and what is the DR2L?
Yeah, so our DR2L is our asynchronous servo motor.
What does that mean?
So it is our AC motor, and it's asynchronous, as the name suggests, but it has a special stator with special windings.
Okay.
And then ran with an SEW inverter, it allows the motor to move as a servo fashion.
Gotcha. So we're getting some of the benefits of this AC motor, AC stator, but then we're getting the capabilities of a servo motor. So what are some of the benefits, or like what would we want to do with it?
Yeah, so it's really used in high inertia applications. So think of those applications with really heavy loads that you're having to move either in really precise dynamic ways or very fast.
Gotcha. So it's going to be maybe some heavier loads, speed control, position control. What are some of these that we would find in the field, or what are some things that our listeners could keep an eye out for?
Yeah, so our biggest target right now is storage and retrieval. So with storage and retrieval systems, they have to move very fast, but then they also have to position exactly to get whatever they're retrieving. So whether it be a box, a pallet, different parts. So it has to move up the line very accurately and quickly and stop at an exact location. Even if it's a couple inches off, then it could be ruined. So we want these to stop at an exact location, and that's what the DR2L allows the end user to do.
Gotcha. And a lot of these SRS storage retrieval systems can be moving quite a bit of weight. So that load, inertia control, positioning sounds like exactly some of the benefits we talked about. Are there any other general applications that they could keep an eye out for?
Yeah, so if you're looking at like gantry robots or picking robots, sometimes you'll see these with like in smaller applications, you'll see servos because they're better at dynamics, or they're the same, but good at dynamics for smaller applications. But again, with these heavier loads, you need something bigger that can handle the higher inertia. So we move into the DR2L.
Gotcha. So you just mentioned servo motors, and the DR2L, as you said, is an asynchronous servo motor. Is there like a kind of commonplace way to think about these or compare them?
Yeah, so exactly. So we have like our regular servo series. We have the CMP, CM3C, and then we move into the DR2L, which is high inertia. So those other two are low and medium inertia.
Right.
Whenever we're talking about inertia, it's really focusing on the application itself. So, and it's going into the weight of the applications. So whenever we think of small inertia, we're not needing a lot of force to get it going.
Right.
Versus a high load, we need that force. And that comes into how big the rotors and the stators are. With a bigger rotor, it's going to help with the inertia mismatch. Now, getting into the inertia mismatch, like a common example would be a camper.
Okay.
So usually we see campers being pulled by really big trucks.
Right.
Like 200 series trucks.
Yep.
Not smart cars.
No.
So, even if a smart car could get the camper going, it wouldn't be very accurate on the going side.
Right.
It might take a lot of torque to get it going. But then on the stopping side, so if you slam on the brakes in a smart car attached to a camper, that camper's momentum is going to keep that smart car going for however long. Versus if you were in a truck, in this case, the DR2L, if you first get it going, it's going to have more horsepower and more inertia to push it along. And then when it comes to stopping, the truck and its weight is going to be able to stop the camper more effectively and more accurately.
So, I mean, I think that's a great real world application right there. You know, servos are great cars. They have their their fit in the marketplace, but they just can't quite control it. And that's that positioning we talked about with the gantries and the storage retrieval systems. So if we're talking specifically about the DR2L, what's some of like the advantages or technical specifications that we can use or our customers should know about?
Yeah. So one is the high dynamics. So with our DR2L, we have two classifications. One is our D1 package, and then the other is D2 package. The differences between those two packages is how thick the pinion rotor is. So with our D2, we have a thicker pinion rotor. So it's able to actually handle a lot more startup torque. So in this case, we get 3 times the nominal torque on the startup end.
Wow, that's awesome.
Yeah. So especially whenever you're getting those heavy loads going, we can easily access that and not break a pinion.
Fantastic. Yeah. So we have our Dynamics package 2, the D2 package. When we're talking about this, it's an asynchronous servo motor. Does that mean it's limited in any of the options or add-ons that we can add on, or does it still have all those benefits as well?
No, it still has all the benefits. So if you think of all the well-known benefits that we have with the DRN motors, so like the brakes, the encoders, connections, we have those all with the DR2L.
So our customers aren't losing any flexibility. They're not losing any of the options that they could possibly use and or benefit from. They're just getting more torque, a little more control and positioning capability with this kind of DR2L motor, asynchronous, synchronous.
Exactly. And the speed as well.
Well, wonderful. Is there anything else we really need to talk about when it comes to our DR2Ls, or have we kind of hit the nail on the head?
Yeah, so just going over some of the specs that we have.
Okay.
So with our DR2L options, we have a speed range from 1200 RPM to all the way up to 3000 RPM. So really encompassing all those applications that might be needed, especially in those high-speed applications. And then the nominal torque of these, since we have such a large range of them, goes from 2.7 newton meters all the way up to 290 newton meters, while the peak torque goes from 5 newton meters to 1,100 newton meters. So really just, it can be used in so many applications.
So we definitely haven't pigeonholed ourselves into just a few. We have a very wide gambit. So we talked about the comparison of the DR2L motors to the servo motors. Is there anything special that we need to know about the DR2L compared to our standard AC motors, the DRN series?
Yeah, so the DR2L will be smaller in frame size because it's more robust in its nature than the DRNs. So especially for saving application space, and your assembly location in a customer's application, it's really going to save space.
Fantastic. I mean, space saving is a huge thing out there in the field, especially when you're getting just as much torque, if not a little bit more, from a smaller frame size. So I think we covered a good bit about the DR2L. Any last cherries on top, or is that about it?
No, that's about it.
Well, fantastic. Thank you so much for coming in today, Anecia.
You're welcome.